How's it going, everybody? Welcome to another edition of me walking you through some math problems here in this Module 4 book. I gotta get a better way to do this. I don't know, whatever. I gotta get a better introduction. Please, give me some help. Obviously, I don't know how to start these things. Need your help. Page 155 is where we're gonna be, okay? So we are kind of picking up and we're continuing to move further along down the line in how we're gonna be using these equations here in the 8th grade. And really this is where the rubber kind of starts to meet the road. This is really where we're going to get into, this is really where we're going to get into what it looks like here in the 8th grade and what we have to be able to do with these types of things. So here on page 155, lesson 15 begins. The lessons that we did before this, lessons 10 through 14, was really kind of laying some groundwork to help us understand what is a two-variable equation. What does that look like in another form? What does that look like when we plug it into a graph? What does that look like when we plug it into a table? What does that look like as an equation? All right, and so kind of being able to put those things together using the information we had from last year and looking at ratios and proportions. We looked at constant and proportionality. We looked at, when we plug x into our equation, what do we get for y? And that's really kind of the gist of where we have been and where we're going to continue to go. The only difference is now we're going to look at not just being able to create a line, not just being able to create an equation, but really comparing them and what they look like in their graph form, as well as, of course, as an equation in a table, and being able to compare them between the different representations. Not just having two graphs and comparing them, or two equations and comparing them, or two tables and comparing them, but going from a table to a graph, or an equation to a graph, and being able to compare them in the given representation, rather than having them both have to be and look the same way in order for them to be able to compare. Okay, so we're really starting to get into the comparison of what these equations look like in different ways, and so we do this for essentially the rest of this module. We're getting to almost to the halfway point, and we do this for the rest of this module, and really we do this as we continue into dealing with functions a little bit later on. So this is kind of our first look at comparing, and the way they ask you to begin to compare is by looking at what's called a slope. All right, and so when you have a slope of a line, essentially if you think about a hill, a slope is how it runs down. Very steep ones have very high slopes. Very, not so steep hills have very kind of, low and very easy to get through and very kind of flat slopes. And so that same kind of thing is going to apply to these lines that we're going to be looking at. We're going to be looking at to see which one is steeper. And so when we have a steeper slope than another one, then we're going to be looking to compare the unit rate. We're looking to compare the constant of proportionality. This is where we tie that constant proportionality piece together with what a slope is and what that means for us, both in terms of our equation and in terms of what that looks like on a coordinate plane. And so we begin here with a graph A and a graph B on page 155. Okay? Essentially, they want to know what is steeper. So, is graph A steeper? Is graph B steeper? Take a second. Tell me what you think, or write down what you think. Hit pause. Okay. So for me, graph B looks to be, can't write. Graph B looks to be the steeper slope, the steeper line. Graph A kind of looks like this. Graph B kind of looks like this. And by steeper, I mean, I hope you know what steep means. We're kind of becoming more vertical at a faster rate. We're not 100% vertical. It's not a straight line up, okay? But we're rising at a faster rate. It would be more difficult to climb this hill than it would be this hill, simply because you'd have to go up further in a shorter amount of horizontal time. That's essentially what determines your steepness. Okay? Part B wants you to write the directions of how to get from one point to the next. And this is where we tie our constant of proportionality, our change in y over x. This is where we tie that together with our slope. Okay? So, in order to get from, let's look at graph A. in order to get from this point to this point, we don't have a direct amount of distance between the 2 points to be able to figure that out. What we do have are obviously all of these little points on our coordinate plane that we can use as a reference. So to get from this point here, which is at negative 2, negative 1, to this one, which here is at 1, 1, we have to go up. So we go up 2, and we go to the right 3. Okay, so we're going positive 2, positive 3. And the reason I'm writing them as positives is because we went up and we went to the right. If you think about a number line, and essentially a coordinate plane is just a vertical number line and a horizontal number line, and they meet at the origin. Up on a number line, think of like a thermometer, goes up, goes vertical, goes positive. Okay, down would be negative. Same thing with a horizontal number line. Okay, to the right of 0 is positive, to the left of 0 is negative, so you move towards the positive side, you are increasing. So we go up 2, and then we go to the right 3. This is what's called the rise and the run. Okay, so your rise is a +2, and your run is a +3. And so when we do that, so here we go, so we go up 2, to the right 3. Both of those are going to be positive. That's how we would describe it. Write the directions for first graph A. For graph B, very similar. Okay, we do the exact same thing. So we go from here, which is at negative 2, negative 1, and we go all the way up here to 1, 3. So we have to look how we go 1, 2, 3, 4. 1, 2, 3, 4. We're going up 4, and then we're going 1, 2, 3 to the right. Okay, so we've got an increase of +1, +2, +3, +4, and then we're going to the right 1, 2, 3, +3. This again is also our rise. This again is also our run. Our increase or decrease in terms of where we go is our rise. So here we went up 4, right 3. Okay? Our increase or decrease is called our rise. And then our shift horizontally, either left or right, depending on where we have to go, is called our run. When we take these two things together and put them together as a ratio, as they ask you to do, is they want you to take the change in y and divide that over the change in x. Very much like our y equals kx, very much like this, where k is equal to y over x. And so we looked at that to find a proportional relationship. We're going to do the same thing here. In this case, we're going to have our rise divided by our run, which would be our increase in y divided by our increase or decrease in x. Our change in y over our change in x. So for graph A, okay, our rise was 2, and our run was 3. So we would say that this would have a constant proportionality, a k of 2/3. Okay, or we would say that it has a slope of 2/3. Let me fold that up a little bit. A slope of 2/3 for A. For B, we would do the exact same thing, exact same process. So we're going to look at the difference in between our vertical, okay, which is our rise. So we're going to go up 1, 2, 3, 4. So when we put that together in our ratio, that's going to go here. And then that's going to be over our run, which is to the right, which is 1, 2, 3. Okay? So we've got 4/3 here, which is our k. Or we would write this and say that we have a slope of 4/3. As always, don't make it a decimal. As always, leave it as an improper fraction. It's more useful that way. Okay? And so when we have these two things, we are comparing their slopes. We said that graph B is steeper, and now we have clear evidence. we have something called the slope, their constant proportionality, their comparison of the same kind of value. Okay, we're comparing how we get from one point on our coordinate plane to how we get to somewhere else on our line. Okay, we're comparing how to get from one place to the next place, and we're doing the same thing on both of them. So because we're comparing the same thing, we're comparing the same look, getting from one place on the line to another place on the line. That allows us to create two slopes that could be compared. When you measure the same thing, then you can accurately compare them. This is what we're doing. We said that graph B was steeper, and what that means is we have a greater value for its slope. Okay? In terms of which one is greater, obviously the one that has a value of 4/3 is greater than a value of 2/3. That should make sense. Okay? So, to wrap all this up, we are looking to define and we're looking to compare the slopes of these lines. Lesson 15 has a ton of examples. We're going to go through a couple more on another couple videos because it takes a second to kind of look at it and compare it and find the slope. But from there, you're just looking to compare, find the slope, knock it down, and then keep it moving. Okay? So, this is your opening exercise with lesson 15. I hope that makes a little bit of sense in terms of where this term of slope comes from and how that compares to what we've just done. So, if you have any questions, hit me up with an email. Otherwise, adios.